let us consider a conductor. Inside the conductor, we are having the electrons. These electrons are not in a moving direction. They are not having sufficient energy to move from one place to another place. So inside a conductor, we are having the electrons, but these are not capable of to move from one region to another region. So these electrons require certain energy to move, to gain the energy. So what we do, we connect a battery or a cell. Okay. So when battery is connected to this conductor, inside the conductor, what's going to happen to the electrons? Electrons gain the energy and electrons try to move from one place to another place in a uniform direction. So when the electrons move in a uniform direction, what's going to happen? Flow of free electrons. All electrons cannot receive the energy given by the battery or the voltage. So few electrons receive the energy. So the electrons which receive the energy and move through the conductor are called free electrons. That's why the definition of the current is flow of free electrons. Okay. And you can see here, direction of the current is taken always opposite to the direction of movement of electrons. Electrons move from negative terminal to positive terminal and current flows from positive terminal to negative terminal. Okay. So these two diagrams you can write if they are asking define the definition of the current. Okay. So inside a conductor, initially electrons are not in a dynamic motion or not in a movable condition. When voltage is applied to the conductor, electrons inside the conductor move from one place to another place. Okay. So after this diagram, so let us take this one. After this diagram, let us take the definition of the voltage. Anyone tell me what is the definition of voltage? Any idea, anyone? Voltage is the energy given to the electrons to make the electrons to move from one place to another place. Okay, which is also called as the EMF. What is the full form of EMF? Electromotive force. So here we have written. Now you can see electrical effort required to drift the free electrons in one proper direction in a conductor is called electromotive force. So in simple language we can write electromotive force or the voltage is the energy given to the electrons to make the free electrons to move from one region to another region. Or you can write this definition: electrical effort required to drift the electrons in one particular direction is called electromotive force. So what is the formula for the current? I is equal to Q by T. Okay. So this is the basic defined current, and electromotive force means you can write the definition. Now let us move to the today's topic here. Now, as I mentioned, second unit is entirely resistors. Anyone tell me what is the definition of resistance? Any student? Resistance. Anyone? See, in a conductor, if you are having 100 electrons, all the 100 electrons cannot receive the energy. Only 90 or 99 will receive energy. They start to move from one place to another place. The electrons which are not receiving the energy are static. So opposition is shown by these electrons. So opposition to the current is called resistance. Opposition to the current is called resistance. Okay. Now, so what is the new topic, all of you? Effect of temperature on resistance. Effect of temperature on resistance. So what is this temperature? How we are supposed to study in our subject? Means temperature means don't think about the sun rays and the climatic condition. What is this temperature? Why it is existing in our subject? Means we say when a battery is connected to a circuit, when a battery, as we have shown the diagram here. So this circuit, if you see, battery is connected. When a battery is connected to a conductor, few electrons, okay, few electrons, they get heated up. Entire surface region of the conductor gets heated up. Heat energy is created. So that's, in this case, the temperature of that conductor is increased. So what is the explanation? Effect of temperature on resistance. So the resistance increases with temperature. So what is the simple line answer, all of you? The resistance increases with temperature. How it happens? If you see this diagram is explaining, these are called free electrons, the electrons which are moving in a smooth direction, okay, in a smooth manner. And this, these are nothing but this, you can see the plus ion, it is there in a circular manner. It is nothing but the electrons which are static. Okay, this arrow marked one are electrons which are moving, and the electrons are the ions which are static here. So what happens when electric voltage is applied? So I'll repeat the same thing here. Under normal temperature, when the metal is subjected to potential difference, that is, when voltage is applied to the conductor, few charges or few electrons will move from one place to another place, and few electrons are constant. Okay. Now, when the voltage value is less, the temperature is also less. The few electrons are constant, but when the voltage value is increased, temperature increases, and these electrons which are static, they start vibrating. They start vibrating. When they vibrate, heat energy is created and temperature also increased. So anyone, is it understand? Is it understandable to you right now? Okay. Once again, I repeat.
Yes.
Right. So what is
Yes,
this
sir.
diagram? Yes. What is this diagram? So all I request those who are joining now, next class onwards, before after 3 we'll never join. Okay. Make you people to join. Please cooperate. What is the topic? Effect of temperature on resistance. So whenever temperature increases, the resistance of the conductor increases. How you are saying this word? And what is this temperature? I should take the conductor, and if I am placing in the presence of sunlight, temperature increases? No. The answer is, for a conductor, when we are applying the voltage, for a conductor, when we are applying the voltage, few electrons move from one place to another place, and remaining electrons are static. When the voltage applied is increased, the electrons which are static, they start to vibrate. Okay. When we are still increasing the voltage, what's going to happen? The temperature of the entire conductor increases, as these electrons which are static initially, now they are vibrating. They also collide with the movable electrons. You can see this figure showing that here you can see the static electron is not in contact with the movable electron. Here we say the movable electron and static electron both are colliding with each other. So during this process, temperature of the material or the conductor increases. So this is the proof. Now after certain period of time, what's going to happen? Heat energy is created and few electrons will collide with each other. Okay, so in simple manner, I'm just repeating this one. Effect of temperature on resistance. Whenever the resistance of a material, the resistance of the conductor always increases with increase in temperature. Whenever temperature increases, resistance increases. What is the proof? Inside the conductor, we are having free electrons which are moving from one place to another place, and we are having the static electrons which are constant. When voltage is applied to this conductor and the voltage value is increased, the electrons which are moving will move at speed equal to speed of light. Okay, they are going to move from one region to another region, but the electrons which are static, they will start to vibrate. If the voltage value is increased, then both the electrons, the static electrons and movable electrons, moving electrons, are going to collide with each other. As a result, temperature increases. That's all. You can write in your own words whatever I am explaining. Okay, this is a textbook explanation, same thing. So I repeat for the last time in shortcut. You have to remember, you have to write. All students make a note of this one. Okay. What is the topic? Effect of temperature on resistance. Whenever temperature increases, resistance increases. Let us consider a conductor. Inside the conductor, we are having free electrons which are moving from one region to another region, and we are having the static electrons which are constant. So when the voltage applied to the conductor is increased, the temperature, when the voltage applied to the conductor is increased, the static electrons start to vibrate. After certain period of time, if the voltage value is further increased, please mute yourself, don't unmute. After certain period of time, if the voltage value is further increased, both moving electrons and static electrons will collide with each other. As a result, the temperature increases. Therefore, when both the electrons are not moving, they are colliding and they are not moving in a uniform direction. You can see here, all of you, they are colliding and they are falling down, the moving electron also. Therefore, as a result, the flow of current decreases and resistance increases. Okay. So whenever temperature increases, the resistance increases. What is the proof? So inside a conductor, we are having movable electrons and static electrons. Whenever voltage value is increased, both static electrons and movable electrons collide with each other. As a result, the flow of current decreases and resistance increases. So all of you, you can write this one in an examination, whatever I have explained just now. Right. Now we move to the next important topic. Any doubts in this topic? If this topic is not understood, I'll explain. This is theory one. Okay, but very important. So
Okay, sir.
as the temperature increases, what will happen to resistance? Resistance increases. Okay.
Increases.
Temperature means battery. We are applying the battery or voltage to the circuit. Right. Now all the students. Now
Excuse me, sir.
Yeah. Please go ahead.
Static electrons means constant electrons.
Yes, constant. See, why constant electrons are created? If you are having one conductor, let us say you are purchasing one copper rod, let us say from electric shop. Okay. Inside we are having the electrons. All the electrons cannot move from one place to another place. That is what I have shown here in the first figure. So inside the conductor, we are having, let us say, 100 number of electrons. When voltage is applied, out of 100, 90 electrons can move, but remaining 10 electrons cannot receive the energy. The electrons which cannot receive the energy from the voltage and which are static are called the static electrons. Understood? And the electrons which move from one place to another place are called free electrons. The flow of free electrons is called the current. Now I hope you have understood. The student who has asked the question, static electrons.
Okay, sir, understood.
Right, very good. So this diagram is sufficient. So in this diagram, we are explaining that first moving electron is approaching the static electron. Okay. And both the electrons are colliding. When they collide, the temperature of the conductor increases. And after a certain period of time, if the voltage is increased, they collide and they fall. You can see the moving electron direction is disturbed. Therefore, the current flow is decreased as well as the temperature is increased. That's all. Now we move to the next topic, which is nothing but the series connection of resistors. Of course, in 10th class, you are having small bit. Now you will do the problems also. Okay. So what is the resistor? Now, all of you, as I mentioned, what is resistance? Opposition to the current flow. Okay. But what is resistor? All of you. Resistor is a property of resistance. Resistor is a practical element which we can touch, which can purchase from the electric shop. Okay. Now I am giving one simple question. Which shop you like? The bakery or general kirana shop or else the electric shop? All of you, from today onwards, our favorite shop should be electric shop. We have to purchase the electrical components. Okay. Resistor, we can physically we can view that one. Resistor connected in a circuit. What it will do? Anyone read out this one? Resistor connected in a circuit. What it will do?
Decrease the strength of current,
Yes,
sir.
you have to remember this one. Many people say resistance opposes the current. Okay, resistance will oppose the current. But which element practically will oppose? It is the resistor. Okay, resistor is a practical element which opposes the current and decreases the strength of the current. Now I am asking one simple question. Why resistor has to oppose? Why we have to oppose the current? Anyone think generally and tell me. Why we have to oppose the current and why we have to place the resistor everywhere. In remote control, we are having resistor. Inside television, we are having resistor. Inside the smartphone, we are having the resistor. Why we have to use the resistor? What is the basic behavior of resistor? Resistor connected in a circuit Here circuit means television, smartphone, anything. Decreases the strength of the current and passes. Now you read. This is important. And passes which current? Safe current.
Safe current.
So in a television, if I am not placing resistor, in a television, if I am not placing resistor, large current can flow through the television. Television gets damaged. Okay. Therefore, we have to place the resistor. Okay. Yes, those students, please, disturbance should not be created. Please cooperate. Okay, right. If disturbance is there, you mute. While asking the question, you unmute. Don't, yeah, right. Okay, right. Now, okay, resistor definition we have seen. Resistor is a practical element which opposes the current. Resistor, today onwards, remember, resistor is a property of resistance. We can see practically resistor. Okay, resistor decreases the strength of current and passes the safe current. Without resistor, we cannot invent any new thing. Okay, now, so note point. No need to write in the examination this note point for your understanding. What we have written, we'll see before we take the problems. Imagine flow of current flowing through the water. When water flows through the pipe, if the water flow is dividing, then we say two pipes are in parallel. Understood? This is not geometry lines. Two lines are in parallel. If the water flow divides, then we say two pipes are in parallel. Okay? And if the current flow divides, then we say two resistors are in parallel. So now we'll take one circuit. You'll understand the note point later on. So first, what is our explanation? Series connection of resistors. All of you can see the circuit, right? All the students. We are having cell. We are having the switch key, on off key. And then how many resistors we are having? How many? This is called resistors.
Resistors, sir.
Yes, these are not resistances. These are resistors. Okay, practically connected. So, sir, why you are drawing resistors? Okay, in your house, let us say you are having fridge, washing machine, and mixie. I cannot draw fridge, washing machine, and mixie here. So, instead of drawing those components, we are drawing resistors. So, all the textbooks we draw the resistors. So, resistors are acting as the fridge or bulb or any device. We are giving electricity to all these devices. Now, what is the total connection? How much current is flowing? This is our subject. Current flow I. Okay. Now, these resistors are connected in series or parallel. We say if the current flow is not divided, if same amount of current is flowing through resistors, then it is called series. Now let me share one particular animation to you. We'll check whether it will play or not with respect to the internet connection. Just hold for a minute. All of you, new slide you are able to see on the screen? Please tell me.
Yes, sir.
Yes, sir.
Sir, we can.
Now you see, right? You see all of your series current is flowing here. Positive terminal to negative terminal. Parallel, this is the parallel circuit now. Okay, current divides. Different current flows in three different resistors. Yes, sir. This is the parallel circuit. Okay, the animation. Yes, now you can see current is dividing here. So this R1, R2, R3 are connected in parallel. If current, if current flow divides, then resistors are connected in parallel. If current flow is not divided and same current is flowing, then the resistors are connected in series. Understood, all of you? If the current flow is divided, resistors are connected in parallel. If the current flow is not divided, same current is flowing, then the resistors are connected in series. So let us check once again. Okay. Okay, we'll come back to that one later on. Okay, now the new circuit is available on the screen, right? All students, anyone confirm? New circuit, old
Yes,
circuit
sir.
is okay, right? Now in the examination, explain series connection of resistors. So connect three resistors in series. You can see the dots here. These dots are explaining the same current is flowing. Okay. So in series, this is called series connection of resistors. So what we have to do here? So total voltage. Okay, so directly we can write total voltage is equal to across each resistor. We are having different voltage. See, bulb takes different energy, fridge takes different energy. Okay, therefore here across each resistor what we are having? V1, V2 and V3. So what is the total voltage applied? Total voltage is the combination of individual voltages. So V is equal to V1 plus V2 plus V3. So it is done by the KVL, Kirchhoff's voltage law. We'll discuss later on. So for any circuit, what is the voltage? V is equal to V1 plus V2 plus V3. From Ohm's law, what is the voltage formula? Anyone tell me? What is the voltage formula from Ohm's law? I into R. Okay? I into R. So everywhere we write I only because same current is flowing. Same current is flowing. Therefore, it is nothing but the current I. Now, V is equal to I into R1 plus I into R2 plus I into R3. So, R is equal to total resistance. I get cancelled. RS equal to R1 plus R2 plus R3. Okay. So, now this is the equation. All of you understood the circuit you have to draw and simple. V is equal to V1 plus V2 plus V3 and followed by the resistances. So, now let us go for the parallel circuit. Okay. Now, just now I have shown the animation. Current starts to divide. How many resistors are there again? 3 resistors. Yesterday people have given the answer. So in my house, which connection I have to use? Parallel connection or series connection?
Parallel.
Parallel. In parallel, what is the advantage? Let us say you are having 3 bulbs in parallel. If one bulb is out of service, remaining 2 bulbs will be on because different current. So here what is the total current? I is entering and at this point I is dividing. I is dividing into I1, I2 and I3. Okay, I1 flows through R1, I2 flows through R2 and I3 flows through R3. Okay, so we say current entering this junction is equal to currents leaving the junction. What is the statement, all of you? Currents entering the junction is equal to current leaving the junction. Therefore, I is equal to I1 plus I2 plus I3. Here we have written parallel circuit current divides. Okay, series circuit current remains same. Series connection of resistors. I is equal to I1 plus I2 plus I3. So from Ohm's law, what is the formula for voltage? Anyone tell me? What is the formula for
V
voltage?
into R.
V is equal to I into R. Okay, voltage V is equal to I into R. From that expression, yes, what is current? I is equal to V by R. From Ohm's law, I is equal to V by R. So I1 means V by R1 because same voltage. I2 is V by R2 and I3 is V by R3. Same voltage. So now we substitute here. We know I is equal to V by R, total resistance. I is equal to I1 plus I2 plus I3. V by R equal to V by R1 plus V by R2 plus V by R3. Voltage taken common and get cancelled. What is the expression for parallel circuit? For parallel circuit, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, all of you. Series circuit, what is the total resistance? Total resistance, R is equal to R1 plus R2 plus R3. For parallel circuit, total resistance is 1 by R1 plus 1 by R2 plus 1 by R3.
1 by R3.
Okay. Now we'll take one problem, all of you. So this you can practice. Draw a schematic diagram of circuit. Circuit means what? A circuit contains battery, bulb and certain wires. The combination of battery, bulb and the wires is called the circuit, simple manner. Circuit contains a battery of how many cells? 3 cells. As I mentioned, battery is a combination of number of cells. 3 cells of how much volts? 2 volts. Okay, we have drawn here. And 5 resistors and 5 ohm resistor. Unit of resistance is ohm. 5 ohm resistor, 8 ohm resistor and 12 ohm resistor and plug key. All are connected in series. Series means how to draw? One after the another. Okay. So the second end of the resistor is connected to the first end. So if you are having 2 resistors, how to connect them in series? We should see that same current is flowing. So I is not dividing. I is flowing through the entire circuit. So these 3 are connected in series. Only you have to draw this one. By practice, you will get this one. Now we'll take one problem. Next problem on this one. Electric lamp which has, so I cannot draw electric lamp. So we take the resistance of the electric lamp. Electric lamp contains certain opposition. How much ohms here? 100 ohms. A toaster, bread toaster. Bread toaster contains the opposition. Resistance how much? 50 ohms. Water filter, resistance 500 ohms, are connected in parallel. So how many resistors we are having here? 3 resistors.
3 resistors.
150 and 500 are connected in parallel and connected to 220 volts. What is the resistance of an electric iron box connected to the same source, which takes this much current? Okay. Now all of you, we must write resistance of the lamp, resistance of the toaster, resistance of the water heater. Okay. What are the given quantities? First we have to write. And then, so one second. Yes. And then they are connected in parallel. In parallel connection, what is the formula? 1 by R total equivalent, or 1 by RP we have taken equivalent resistance, or 1 by R equal to, what is the formula for parallel connection? 1 by R1
1 by R1 plus 1 by R2 plus 1 by R3.
So we'll get after LCM this value. So what is the problem they are mentioning? Resistance of electric iron. Okay. One more resistance, one more iron box is added to the equivalent resistance. Therefore, what is the equivalent resistance? 31.25. They are connected in parallel. So total resistance is nothing but V by R. Total current flowing through the iron box is nothing but V by R. So last what they have asked, to the same source takes as much as current. What is the current? That means 3 resistors, how much current it will take? It is taken by the electric iron. So all 3 resistors are replaced by electric iron box. So we write here, in the place of all 3 resistors, total resistance is the total resistance of electric iron. They are connected 31.25, and we require how much current is flowing through the iron box. I is equal to V by R. Voltage is how much given? 220. Okay. So first day you practice these problems. Next class I will explain once again based upon your doubt. Okay. So instead of writing all the students, this is the simple one only. So what is this formula? All of you remember, instead of writing always 1 by R1 plus 1 by R2, if 2 resistors are connected in parallel, we say R1 R2 by R1 plus R2. Repeat anyone? If 2 resistors are connected in parallel, what is the total resistance? Instead of writing 1 by R1 plus 1 by R2, we can write R1 into R2 by R1 plus R2. We'll discuss that one later on. Okay. So let us take one complicated circuit. All of you, let us take this problem. Okay. Calculate the resistance in the following combination. Anyone tell me what we have to do? This is the circuit. Okay. So how 666 are connected? Anyone tell me?
Parallel.
Okay, because current starts
parallel connection.
So 1 by 6 plus 1 by 6 plus 1 by 6. Here we have written how much? 1 by 2. That new resistor will be in series with the 3 ohm. Yes or no? That's why we are taking plus. Okay, new resistor. So entire material will be shared with you. You can see the question, practice. Now you tell me, all of you, battery is 4. This is ammeter. And now you tell me what we have to do. 3 and 2, how they are connected?
Series connection.
Series. So here 3 plus 2, it will come 5. How 5 and 5 are connected? Parallel. So 1 by, yes, R equivalent. 1 by R is equal to what we have to write? 1 by 5 plus 1 by 5 equal to 2 by 5.
2 by 5.
Resistance, yes, resistance will get, then we are going to calculate the current. I is equal to V by R. So in our subject, we have to calculate how much current flows through the circuit. Now you see, all of you. Slowly you can practice. I will explain all the problems also. Now read out this question. What is the question? An electric lamp. Yes, lamp is given here, bulb. What is the resistance of the bulb? Every object has got the resistance opposition. What is the resistance? 20 ohms. And a conductor. Conductor means this copper wire. Okay, and a conductor of 4 ohm resistance. Okay, conductor resistance also given 4 ohms are connected to 6 volts battery. As I mentioned, cell means only one vertical line and small line will be there, positive and negative. Battery means particular indication. Calculate total resistance. Tell me here, current is dividing anywhere or same current is flowing? Current is
Same
not
current.
dividing, same current.
Same current.
So bulb and resistance are connected in series. Yes or no? Therefore, what is the total resistance? Tell me. 20 plus 4 is nothing but 24. Total resistance is nothing but 24.
Yes.
And what is the current? I is equal to V by
24.
R. V by R. What is the V?
V
6.
by R.
I is equal to 6 by
6 by
24.
24.
That's all.
24.
These problems only will be there if at all they are asking. Okay. So voltage, if they are asking, you can calculate I into R1, I into R2 at bulb and different resistance. So let me take the complicated problem, all of you. You tell me this circuit. The circuit is called the, all of you see, this is not series, not parallel. It is complex, combination of series and parallel. It is the complex, okay? Now you see how to solve this one, right? So 12 volts battery is connected to this circuit, okay? Now you tell me how to solve this one. How these two resistors are connected, anyone tell me? We can draw the resistors by box also. Same current is flowing, yes or no? Current is not dividing. I1 is the same current. So R2 plus R3. So here we have written R2 plus R3, 8 plus 4 is how much? It is 12.
Equals 12.
Okay, so now you can see the second circuit. Now it has become 12. Okay, now how these two are connected? See here current is dividing from this junction. Here same current is coming, but it is dividing here I1 and I2. So what is the equation?
I2.
Current entering the junction equal to currents leaving the junction. Okay, currents entering this junction equal to currents leaving the junction. How many currents are entering? IT. Here we are assuming I suffix T is the current. And how many currents are leaving this junction? I1 plus I2. Okay,
I2.
I1 plus I2. So we say
I2.
these two are in parallel. Parallel means what? 1 by 12 plus 1 by 12.
1 by 12.
Yes, 1 by 12 plus 1 by 12 we have done here. You can see. And it is nothing but 6 ohms you are getting. Okay, total combination. 1 by R you will get, but you have to reverse that one 6. Now you see what is the leftover one? R1. What is the leftover? Yes, yes, please. Yes. R1 is leftover one. These two parallel combination we have done. Let us take that parallel combination. So leftover R1 is 6 ohms and the newly combination is 6 ohms. So now you tell me these two are connected in series or parallel? Current is dividing or same current is flowing? Same current is flowing. Therefore, they are connected in series. 6 plus 6. Total resistance is 12. And what is the current? I is equal to V by R. Battery voltage is 12. 12 by 12 is the 1 ampere. Okay. So unit 2, we are having 3 topics first, and tomorrow we'll do the next off. Tomorrow and day after tomorrow we finish the unit 2 also. Okay. So Monday I'm keeping exam on these problems. All of you. I will keep exam on these problems Monday. Prepare well. Today I'm just placing this one in the group. Unit 2, separate material. Unit 1, all of you are having no material. All of you, all students.
Yes, sir.
Many students are having asking one doubt. Sir, we have to write in the classwork or not? So what I am saying, all the students, please listen. If disturbance is there, please mute yourself. Okay. So first you read number of times, understand, and without any pressure, slowly at free time you write. Understood? So temperature of resistance in your own words you can write. Okay. However, I will keep exam, I will tell you, but you prepare today and tomorrow. Okay, resistance. So only unit 2, what we have discussed today, and those problems, there will be exam. Okay, right. So
we can prepare unit 1 or unit 2?
Only unit 2 first for Monday exam. Monday exam, prepare only unit 2, what I discussed. Unit 1 also you study, but slowly you can study. For Monday exam, it will be unit 2 only. Okay. Any questions still? Whatever we are having in the material, that is enough. Okay. External examination, just like maths, physics, chemistry also, this is one subject. This is the tough subject actually. Okay. As we move on to this one, problems complicated, magnetic energy, which is the most important energy we have to generate. See, all of you, one simple logic I'm telling you. So this environment has got natural resources, but as an polytechnic engineer, we can develop the magnetic energy. So third unit is all about magnetic energy. Second unit is entirely resistors. Okay, next class also we'll see the what are the different type of resistors we are having. First unit is only basics of electricity, AC fundamentals. Any question is there, anyone? Okay, let me go on. Okay, just I am ending the meeting, right?